Now it's my honor to introduce today's distinguished speaker, Mr. Sabyasachi Mukhopadhyay. Mr. Mukhopadhyay is a PhD research scholar at Center of Computational and Data Sciences, IIT Kharagpur, and he is a recipient of prestigious Chanakya PhD fellowship under uh, IIT Kharagpur with over 55 publications, including patents, books, and journal articles. His research contribution has been featured in leading publications like The Hindu, The Economic Times, and Business Standard. Beyond academia, Mr. Mukhopadhyay has extensive teaching and mentoring experience. He has held many prominent academic positions like assistant professor in business analytics and visiting faculty in healthcare analytics at renowned institutions like Symbiosis International University. He has delivered many invited talks and hands-on sessions in top institutions like IITs, NITs, international universities. His expertise spans diverse fields like data science, machine learning, deep learning, explainable AI. Now, also he has two-time TEDx speaker and has been recognized with numerous awards for his innovation in research and contribution. So today's session will provide a comprehensive understanding in explainable AI. The session one, which will be from 10 a.m. to 12 p.m., will cover introduction to explainable AI, its importance, techniques like SHAP and line, and its challenges. And in session two, which is from 1 p.m. to 3 p.m., will dwell into practical implementations, case studies, real-time applications. So, once again, I extend a warm welcome to all of you. And let us make today's session an interactive and enlightening as possible. So, without further ado, now I'll invite our esteemed speaker, Mr. Sabyasachi Mukhopadhyay, sir, to take over and lead us into fascinating world of explainable AI. Over to you, sir.
Thank you very much, madam, for the invitation and for this generous introduction. So it's my pleasure to take the hands-on session in this prestigious FDP event. So let us start our discussion. So as this is a hands-on session, so all of you know that we are going to implement it practically through the coding platforms. Here we will use for example, the coding platform like Google Colab, because we are going to use the Pythonic platform framework for implementing the codes of the explainable AI. So definitely we shall have some brief overview on the topic. Why, what is explainable AI, why it is important and relevant to today's world, and then gradually we shall move towards the hands-on part. Okay, so let me share the screen. So those who are aware of the Google Colab, it's fine. Those who are not, for them, let me just show how to access it. Hmm. So in Google, you can, I think the screen is visible to all of you. So in Google, you can simply search Google Colab. Okay. So this is the Colab spelling, COLAB. Okay. And you can click on Google Colab and open it. Okay. For example, once you open it, you will see the plus notebook button is available. You can click on the plus notebook button. Plus new notebook button. Okay. So this is the Colab window. You can put some name there. Like for example, already there is one name FDP demo one. So I'm giving the name FDP demo 2, for example. You can put some name as per your wish. Okay. So this is the naming place. You can put some name as per the requirement of the your implementation. Okay. So once you open up, you can see there are two options: plus code button, plus text button. Okay. So this plus code button, if you click, our coding cell will open up. Here you can write some code. This is the run cell button. You can execute it, and you will see some runtime will be shown here. There will be plus text button also. So once you click the plus text button, you can put up some text there. Okay. For adding the explanations. So in this way, you can do the entire stuff. Okay. So this is how the entire things are being executed. Okay, so let me go back to the original notebook session. Okay, so this is the original notebook. Now I believe that the entire concept is quite clear to you. Okay, that what is explainable AI and how to implement it. Okay, now like I mentioned that you can, apart from the code part, you can add the text part also. So for your assistance purpose, I have added the text here so that you can easily understand that concept and you can implement it by yourself. Okay, so these notebooks will be shared to all of you. Also, I will share my GitHub details so that you can practice at your home whenever you have adequate time. Okay, so in at first, what we will do, we will see the brief overview of the explainable AI, and the first step, like Madam mentioned, that we shall see the explanation generation with the help of the live and SAP-based methods. Okay, so in this particular notebook, what will we shall learn? So participants will gain a fundamental understanding of the explainable AI. In short, we write them as in abbreviated format XAI, concepts and techniques, and apply them to a simple machine learning model. Okay, so as a start of the beginning, then in second half, we shall also discuss about the deep learning and the implementation of the explainable AI at that place as well. So if we see the overview and importance and applications, so first of all, what is explainable AI? So explainable AI is referring to the artificial intelligence models designed for providing the clear and understandable explanations of their decision making process. Okay, and like all of you know that in generally we call the traditional AI black box model. Okay, but to avoid that type of the black box scenario, XAI basically offers the insights that, for example, how to make the decisions or how to make the predictions, or for example, how to enhance the accountability, trustworthiness, or transparency. So, because of that reason, explainable why is getting much more popularity day by day. Okay, so it is enhancing the reliability on the AI model. Okay, trustworthiness. Okay, and as well as the accountability, which was not there in earlier, and people used to refer traditional AI as the black box model. Okay, now if we in a nutshell, if you want to check the importance or the significance of the explainable AI in one by one, so the first part which we like always we highlight, that the transparency level. Okay, data transparency. We are nowadays a lot of laws are being made for making the data transparency, and people are also working on that. Okay, so
So, are you there?
AI-driven system. First of all, second one is very important. That is the accountability. Okay, so accountability once comes up whenever you can reveal the decision logic and it can ensure that errors or biases can be detected, explained, and corrected. Okay, followed by the regulatory compliance. Okay, so it holds it aids the organizations in adhering the regulation like GDPR, GDPR, regulatory compliances are also very important. Along with that, definitely we can talk about the ethical considerations. So, ethical, I mean, the explainable AI XI can prevent the unintended consequences or biases from going unnoticed in critical applications. So, we can talk about the application areas like finance or the healthcare. Okay, so that's how you can see that this is the you can easily understand the significance of the explainable AI, and that is why it has been included in your prestigious FDP also as one of the topic. So applications of the explainable AI, whenever we shall discuss, like I mentioned that already, we have mentioned the fields like healthcare and finance. So if we go in a little bit deeper to check the what type of the applications can happen, like for example, it is crucial in terms of explaining the medical cases from the AI system, like clinicals or patients, and ensuring their life-saving decisions. So, for example, if somebody is suffering from diabetic retinopathy, okay, now you can apply some AI algorithms there. It can be machine learning if you have the large amount of a data set in order of 10 to the power 5, or nearby that you can apply deep learning there. You can have the early diagnosis uh, of the of the diabetic retinopathy, which is the major cause of blindness. Now, not only that, it will give you the accuracy. Okay, it will give it can act as a positive catalyst for the doctors to help to assist in their decisions. Okay. Now, along with that, explainable AI, what it can do, it can, for example, if you want to make some app, okay, now it can generate the explanation depending on the stages of the diabetic retinopathy. Okay, so it can be the binary classification, it can be multi-class classification case. Okay, accordingly, explainable AI will put the interpretation of the patient status. Okay, so it will help the doctor also, and it can give some guidances to patient also that what can be the further steps. So that is how the explainability happens. Okay, so for example, in finance case, in loan approval or the fraud detection. Okay, so it can provide the clarity on the factors which can influence the decision, and it helps to enhance the fairness in the decision making, and also reduces the bias, which is very much important for any transparent system to reduce the bias. So finance section, we will see one of the very interesting example during the case study part. Most probably in second half, we shall discuss, and we shall do the hands-on part by analyzing the real world data set to check that how explainable AI can make the decisions in the terms of the loan approval. Okay, I mean there will be some classifier which will make the decision. Explainable AI will add the explainability to assist the decision. Okay, so and along with that, definitely autonomous system. So this is the in industry 5.2, we are seeing there are the popularity of the self-driving cars are also increasing, and rather than telling them a robot, we can call them as the collaborative robot. Okay, so cobot, in short, cobot. So you can see a lot of, even in government of India, they're also giving a lot of funds for the collaborating robots, how they can assist humans in cyber physical system, how they can work in human centric manner, because today's industry 5.0 era is the human centric era. Okay, so whatever the technologies tools are being developed, it should be utilized for the human benefit purpose. Like explainable AI, it is assisting you in terms of generating the reliability factor or the accountability cases. Similarly, cobots also work with the human in parallel. Okay, so explainable AI can make the decisions made by the system in real time, enhance the safety and user trust, and along with that, definitely the legal system. So it can also support transparency in the automated legal decisions, offering reasoning that can be, for example, adapt these fairness and the compliances with the laws. So as a nutshell, you can say there are many application areas. I have highlighted a few, just just few major areas. Okay, so in a nutshell, what you can say that it is very much pivotal in terms of the decision making in ethically and trustworthiness. It is also enhancing the trustworthiness, and it is very much useful in high stakes of the industry for understanding and the important decisions in essential, which is essential for the users and stakeholders. Okay, and then we will see the key concepts, few of the key concepts. Okay, so few of the key concepts, like I told you, that the black box model, okay, interpretability and explainability, which we see the so like we have seen earlier that in black box model cases that internal functionality of working which are not clearly understood by the human, but they can produce the accurate results, and but these processes behind their predictions or decisions still remain in opaque. So for example, the how the complex ensemble models are working, or the how the deep neural network actually works, people doesn't know. We are giving some input, we can understand there will be some feature extractions during the hidden in the hidden layer with the help of the convolutional layers present there, and then we will do the downsampling with the help of the max pooling layer, and flattening will make them it will basically unfold the data from 2D, if it is an image, from 2D to 1D, and that we are getting the output. Uh, but still there are few areas which are not very much clear to us, so explainability can add up the additional benefit there. Then interpretability, okay, so it will add up the ability to the understandable relationship between the input data and output data. Okay, and it is only possible when you add up the explainability factor there. Otherwise, it is too mechanical way to understand it. Or for example, the another important part, okay, already explainability, I have mentioned that, so I am not repeating it again. Okay, so these are the few of the key concepts whenever we talk about the explainable AI. So black box model, interpretability and explainability. So I elaborated a little bit about the black box and black box model and the interpretability. I'm not repeating again on the explainability because we already discussed those things. Okay, so now we will see the techniques for the explainable AI. So SHAP, LIME, and GradCam. Today we shall cover three hands-on. I mean, three of these topics in the hands-on sessions. So there are many more tricks are available, but these are few popular tricks. Okay, so let us see what is SHAP. So SHAP stands for the Shapley additive explanation. So whenever the naming has happened, as per the inventors, so they use the first two letter of the Shapley SH, okay, then A of the additive, and explanations they have taken the P. Okay, so this is how it is forming the Shapley additive explanation. So SHAP is based on the cooperative game theory. Okay, so it assigns the Shapley value. Shapley value means important value. Okay, to each of the features based on its contribution in the model predictions. Okay, so it provides basically very much mathematically and consistent explanations, okay, of the model, okay, and it offers you the global and local interpretability. Okay, so it will give you the idea that how much the feature is important in contributing the output, okay, and in contributing predictions. Okay, so along with the SHAP, there is another very popular technique. Okay, so that is the local interpretable model agnostic explanations. Okay, like LIME. Okay, so in LIME, what does it do? It basically explains the individual predictions by approximating the complex model with a simpler interpretable model, okay, locally around the instance being explained. Okay, so by perturbing the input and observing the changes in output, it can create a locally linear surrogate model which can help to understand the feature specific decisions. So in a nutshell, whether it is SHAP or LIME, we will see that how it is influencing the output. Okay, so that will be clear once we will do the hands-on session. Okay, the picture will be much clear that how it is helping that to interpret that which feature is more prominent in the decision making, which is less active in the decision making, and which is not at all participating in the decision making. So very beautifully with pictorial representation and the corresponding interpretation, it will be easier for us to understand those concepts. Okay, along with the SHAP and LIME, there are other models which are also very useful, like the saliency maps. Okay, so it basically highlights the most relevant part of the input and made very commonly used in computer vision. So how the neural networks are making the decisions through the saliency map, you can check. Okay, so what will happen by computing the gradients of the output with respect to the input pixels? It can reveal that which particular area of an image is contributing most to the classification. Okay, so mainly image-based cases, many cases you can see saliency map is also very popular, and that's why in image processing related techniques or in computer vision related techniques, you can see the application of it in terms of enhancing the explainability. Okay, and then definitely the GradCam. GradCam is also a very important technique. Like it stands for the gradient weighted class activation mapping. Okay, so GradCam we will cover up most likely in second up, and during the deep learning session we will see that how GradCam is very much useful. Okay, like for example, it can be used in convolutional neural network or CNN to provide explanations for the image-based models. Okay, like we talked about the saliency map, GradCam also can become very much useful, okay, for generating the interpretation of the explanation for the image-based model. So it can produce a heat map that can show the regions in the image where the model focused when while making a particular prediction. Okay, then other methods are also popular there, like for example deep lift. It stands for the deep learning important features. Okay, so here the naming is also very much interesting. If you see, it is taking the deep of the deep learning, then it is taking L of the learning, I of the important, and F and T of the from the features, which has been highlighted in capital letter. So in this way, it has been named as a deep lift. So it also compares the activation of the neuron for a given input to a feature input and assigning the contribution scores to input features. So it is designed to address the limitations in traditional backpropagation method of explaining the neural networks. Okay, and along with that, there are techniques like counterfactual explanations. So in counterfactual explanations, what will happen? So it basically explains the model decisions by showing how the outcome can change if certain input features are modified. So that's a very interesting thing, that if I change certain features, so definitely it will have the effect on the output. Okay, because features are playing a main role in your predictions. Okay, so now what, through the explainability, can we make that transparency, that what is happening internally. So these counterfactual explanations are actually very much effective on those cases. Okay, so this provides the user with insights that how small changes in input can affect the predictions, and useful high stakes decision making areas like finance or the healthcare. Okay, so and another remaining technique is the anchor. Okay, so there are other techniques also available, but I have highlighted few of the popular techniques here. So each of them has their own strengths and lacuna. So if we talk about the anchors, it works as an if then rules. Okay, so it serves I mean, for example, it can offer the high precision explanations by identifying the sets of conditions which we are referring as the anchors. Okay, and that are highly likely to lead to a specific outcome when satisfied. So among these seven techniques which I mentioned here, we shall cover three during our hands-on sessions: SHAP, line, and GradCam. Okay, so let us move to the next portion. So I am already, we have discussed all those parts, so I am just highlighting that, just the names. So ethical and social implications of the explainable AI, it's a very much pertinent area. Okay, so definitely trustworthy and accountability I already highlighted. Bias and fairness, okay, that to expose the decision making process, entire decision making process, so that people can easily understand it. Okay, and it is being very much used for the hiring, loan approval, law enforcement purpose, where the biased decisions can perpetuate inequality. Okay, trust and adoption, I already mentioned that. Ethical decision making, okay, like for example in sensitive application areas like medical diagnosis system or autonomous vehicles. Okay, so it actually empowers individual to challenge, correct, or the make informed choices based on the AI output. So this reduces the risk of the users for blindly following any AI based recommendations. Regulation compliance, I spoke about the GDPR earlier, so I'm not repeating it. Risks of the oversampling. This is very interesting scenario. Like, while XI aims to make the complex model understandable, overly simplified explanation could mislead the user also. Okay, so giving, it can give you a false sense of the understanding. So ensuring that the explainable can be both accessible as well as accurate, so that critically you can prevent this kind of the issues. Okay, so if we talk about the future direction of the explainable AI, so that can be very interesting to see. So improved model agnostic methods. So future research, okay, can focus on developing more robust model agnostic XI techniques that can explain that any AI system, regardless of its underlying architecture, whether you are using ensemble based method, random forest, decision tree, support vector machine, or deep learning, doesn't matter, or the interpretable deep learning. So as deep learning and deep neural network grow in complexity, creating more interpretable model will be crucial. So innovations in transparent architecture and integrating explanation mechanism within neural networks will likely emerge. Okay, so interpretability is another very important factor. Then the human centered XAI. So it can focus towards the shift generation explanation. Okay, for example, different user type can be there, like the decision makers, okay, lay people, there can be experts, by creating user friendly and more intuitive explanation which can align with the human cognitive processes. Okay, so human centered is another very important area. And then definitely the regulatory driven explanation. So as we have seen that with growing emphasis on the AI regulations and the ethics, okay, so XAI will increasingly incorporate the legally compliant explanation to ensure AI system can meet the accountability standard as well as the transparency standard. Then explainability in real time. So we have spoken about the explainability, but can we get them in real time? So there are a lot of researches are going on there. So real time factor and the dynamic explainability will become a very much key direction in near future if we see, and it will have the automatically if we use our common sense, those who have understood it. So we can easily understand that in autonomous vehicle will be one of the areas where you can apply deploy them in terms of the real time explainability factor. Then definitely financial trading, healthcare. Okay, like in early detection of the cancers or the diabetic retinopathy, those are the chronic diseases. There we can easily apply them, and we can expect some quick explanations and quick and accurate explanations that can give the patients and doctors a proper direction. And bias detection and fairness auditing. So XAI tools will evolve to help detect biases in AI systems by explaining and auditing the decision making processes. So it can enable more equitable and ethical AI deployment across the diverse population. So in a nutshell, if we see in future, it is going to play a significant role in ensuring fairness, trustworthiness, and ethical AI. We will see will be used in various domain. I mean, and behind the ethical AI, okay, XAI will play the pivotal role behind the success of the ethical AI. Okay, so now what we will do, we will start the hands-on session. So at first, we will install the Sklearn, Pandas, Matplotlib, Seaborn, Lime, and Chap. Okay, so it will work. Doesn't you do not have to worry. So initially, you can see some package-related issue. They may be there, but it will work. So you can just install here. So like for example, FDP demo one, I am putting it here. Okay, it's a very simple single line of the code. Okay, and for your assistant purpose, I have commented. So those who are new to Python or Pythonic platform, let me tell them, along with the code, I can add some explanations of the code. So you can use the hash sign. Okay, so it will help you to while during studying at your home or practicing, it will help you to understand the each step. So at the first stage, okay, we are doing the Sklearn. Sklearn will help you to implement the machine learning related stuffs. Pandas are very much important while dealing with the data frames. Okay, Matplotlib will help you to generate the plots smoothly. Seaborn basically add on the extra color palettes along with the Matplotlib, and it helps the Matplotlib to behave like MATLAB. Okay, Lime and Shap are the explainable AI techniques, so that's why we are using them. So these are the tricks. You can install them in all together. So pip install is in general comment, but in whenever you are doing it in Google Colab, one add up the one exclamatory sign there. Okay, so you can click on it. So it will meanwhile it will execute. So once it will execute successfully, a green tick will appear. Okay, so this is the very simple part. So all of you please type it. Okay, so it's now 10:35. Please do it in next 2 minutes. By 10:37, please complete the step. Hmm. So you see this green tick will appear. If some error will happen, so it will be this run cell button will become red, but it has smoothly executed. So 2 seconds, okay, is the execution time. Sometimes it can be 0 seconds, sometimes it can be 8 seconds. So this green tick will appear. Okay, so I'm going back to the original notebook. So please type it carefully so that there should not be any mistake. And those who are new to it, you may face some difficulty. For them, I am also posting it in the comment box section. You are encouraged to type, but I will give you some time for the typing also. But those who are new, for them, once the assigned time is over, I will post it in the comment box so that everybody can do it with me. Okay. So already the assigned time is over. So that's why I'm posting it in the comment box so that everybody can easily implement it. Box is not appearing. The chat box is not working actually. It is showing we are having trouble loading your messages. Try refreshing.
Yes, sir. Actually, it has been disabled for outside organization participants by the college administration only. But we can use the question answer session, sir. Question answer.
So can I post it in the
Time.
Q&A section?
Yes, sir.
Okay. Thank you very much for your guidance, madam. So, everything appear. Okay, so I am posting it in the Q&A part. Okay, so please copy from there. Those who already typed it, very good. Those who are facing difficulty, please copy it from the Q&A section. Okay, so let me go back to the screen sharing mode. Okay, so now let us move to the next part. So it will be the random forest-based iris flower classification. Okay, so in the basic step, as we can see, what we will do, we will basically will discuss about the iris dataset, iris flower classification in this particular segment. Okay, so import numpy. We will first, at the first step, we shall import some of the very important libraries. Okay, like import numpy as np, import pandas as pd. Okay, and from scalan.dataset we shall import the load underscore iris. Okay, so here in this example, iris dataset is the inbuilt dataset present there, so we'll load them. Okay, and then from scalan dot model underscore selection we shall import the train test split. Okay, so that we can have the train and stitch test split of the given data set. Like for example, we may use 70% or 80% of the data set for the training purpose and remaining 20 to 30% for the testing purpose. And then from scalan.ensemble we can import the random forest classifier for doing the classification task. And also from scalan.metric we will import the accuracy score. Like you may remember that scikit-learn is very, scalan stands for the abbreviated format of the scikit-learn, and is very much important for implementing the machine learning stuffs. Okay, so you can type up to it before loading the data set. You can type up to the import libraries. Okay, so it's now 10:41. Please complete this step by 10:44. Okay, if you are unable to do that, then I will post it in the Q&A section. But you are encouraged to type it. Okay, I will post the entire part and you will get all those notebooks fine. But try to do it now, so you will get the essence of the entire session. So that's why I am encouraging you to type it. So please complete up to this importing libraries, this highlighted section. Just finish this part. So in iris dataset, there we will check whether it is iris setosa or iris versicolor or iris virginica. Okay, which class the particular flower will belong to. So there will be total 150 samples, and classes are very well balanced. 50 samples of the iris setosa, 50 samples of the iris versicolor, 50 samples of the iris virginica, and there will be 4 features: sepal length, sepal width, petal length, petal width. So gradually, when we shall progress, I will definitely explain. Now we are only doing the importing of the libraries. Okay. So I shall wait for a couple of minutes more, and then we shall move ahead for the next part. That is the loading of the dataset. So we are using the inbuilt dataset present in the package under the sklearn.datasets. And during the case study part, we will see that how to implement these concepts with the real world dataset also. By accessing the external dataset, we shall do that. Okay. So we'll see both type of the examples, accessing external datasets and also the inbuilt dataset. So here we are doing it on the basis of the inbuilt dataset, that how we can see the predictions made by the classification model and followed by the generation of the applications. Okay, so let me share the all those who have already finished it, fine, and those who are still yet to finish or having facing problem, for them I am putting this part in the comment box also. So I am putting in the same section, Q&A section. Okay. So I have posted it in the Q&A section. So please go through them. Okay. So those who already have finished it, fine. And for those who are unable to do it or facing some difficulty, so I have posted it in the Q&A section. So there might be some word limit. So entire thing has not gone. Just a second. Let me check. Okay, so I will post it in split. Okay, so ignore this particular message. Let me post in split. Okay, because there are some word limits. Okay, so because of that, the entire thing will not go in all together. So I'm posting it in split.
Sir, or what we can do is I have added you in WhatsApp group, and I have made you admin also, so you can post the messages also there also if it is not working with Q&A.
No, it's fine because I am not using my WhatsApp in laptop, so it will
Okay.
work. Okay, so I'm posting it in split. Okay, no problem.
Okay. Sir.
Do not worry. I have checked the issue because I saw there are some dotted lines are appearing, so I understood there are some issues. No problem. So up to train test split, I have posted one part. So please copy this. This is the part one, and part two I am again posting. Okay. So I have sent two text in the Q&A section. So past part one, you will see up to train test split is there, and part two, you will see it will start from the sklearn.ensemble while you will import the random forest and accuracy score. Okay. So I'm going back to the original notebook. You can match with the original notebook. Okay. Okay. So I'm back to the original notebook. You just take a look while merging the two parts. Please take a look. Those who have finished it, fine, and those who are doing it, please take a look on it. Okay. So let us also see the loading of the data set. Okay, so there are very simple comment. This is for the inbuilt data set, like I mentioned. Okay, so for example, during doing loading the external data set, you will see we will do in some separate tree. So you can consider these codes as a standard template for you. So while during your teaching maybe or during your research, you can use them. You can play around them. Okay, so it will give you a lot of confidence. Those who are new to this field, they can get a lot of confidence. So data equals to load underscore iris. So you have stored the iris data set under the data variable, and then pd dot data frame. Okay. So here what we'll do, we will put columns equals to all the data feature names. Okay, sepal length, sepal width, petal width, these four are the features. We will store them under capital X. Okay. So this will basically your predictor variables, and the target variable will be Y. Okay, there we will basically put the target. Okay, like which type of the category it is, iris setosa, iris virginica, or iris versicolor. And then what we will do, we will implement the 10 test split. Okay, and then there will be four argument sections. Okay, the first two area we will put up the predictor variables and the target variable as X and Y. Then we shall define the test size as 0.3. Here test size 0.3 implies 30%. So 30% will be utilized for the basically your entire data set. 30% will be for the will go for the test data part, and remaining 70% for the training. In generally machine learning, this is the standard policy what we do. As per the experts, we use 20 to 30% for the training testing part, and remaining 70 to 80% for the training part. Okay, so like from your common sense, you can see that test size 0.3 means it will go 30%. If it is we are keeping 0.2, that means 20%. If it is 0.25, it will be 25%. Random state 42 we are keeping. We keep some random state value integer, so that whenever we are reproducing the result, the accuracy should not change because of the randomization. Okay. So loading dataset and split dataset into training and testing, you can implement this part now. Okay, you can type and complete implementing this particular part. So it's now 10:52. So please finish this part by 10:55. Okay, and for your assistant purpose, at the end I will drop this particular chunk of code in your comment box section, the Q&A section basically. Okay. So I am encouraging all of you to please type, so that those who are new especially, they can become accustomed with this type of the platform. Okay, it will become more more interactive session in that case.
Uh, Excuse me, sir.
Yes, madam. Yes, sir. Please.
Sir, I am Dr. Nirmal Sen. I
Yes, sir.
also did my PhD. I also did my PhD from IIT Kharagpur.
Excellent.
Sir, is it possible that can we get your email ID so that after this session also we can
Sure, sir. I will
in
share
the
my email ID. Do not worry. I will share all my official
okay, okay,
social handles, and along with that, I will share the other resources also. My GitHub link,
okay, okay,
okay, my YouTube channel,
okay,
and the
okay,
Medium article where I write the article about these things, so that people can build their career on this domain. So I will share all the resources, sir.
okay,
Hmm.
okay, okay. Thank you,
Nice to
sir.
know you, sir. Thank you very much for
Okay,
interacting
thank you,
with
sir.
me. Okay, so I believe that all of you have been able to finish this part, and those who are unable to do it, for them, I am just posting it. Hmm. So kindly check and hope this will helpful to you. I posted it in the Q&A section. Kindly check. Okay, I can see. Okay, so it is not coming fully. Just a second. I did me repost. It is not coming fully. So I have to post it in split. So how much it has coming? Let me check. Target data target up to data target. Let me post. So in the first section, I am reposting it up to uh, defining y. That means target variable. So it will go fully. As I can see, the problem is occurring after that. Okay. Okay. So I have shared the first part up to loading the data set. Then I am sharing another part, that is the splitting data set into training and testing. Hmm. So I have posted the second part also. Now, kindly have a look. Please check. Okay. And for your uh, you can also cross check with me. Let me just do the screen sharing. You can easily cross check. Okay. Now you just cross check with me for this particular part. Okay. So once you are aligning them, so first put the load data set part. Okay, which is ending y equals to pd dot series data target in the index target is mentioned, and then split the data set into training and testing part. Okay, so please implement up to this. Okay, now we shall discuss about the next part, next portion, that is training a random forest model. Okay, so in that case, what we will do, we will take the random forest classifier function. Okay, and we shall keep the n estimator equals to 100. So all of you knows who are aware of the random forest, you know, basically we follow the ensembling approach. We take the ensembling of the decision trees. Okay, so here we are taking n estimate data, means the 100 trees are working all together. Okay, and random state we are keeping 42 to avoid the randomization in output, so that we can get the same output in every time. And model dot fit, this is the standard practice. It will be executed over X train and Y train. Okay, so this is the first part we are doing in terms of the training the random forest model. Okay, and then in the next part, what we'll do the model evaluation. So in the model evaluation, what we'll do, we'll apply the model dot predict over X test. Okay, and we'll assign it as the Y pred, and then what we'll do, we'll print the accuracy score by taking Y test and Y pred, and you will get the accuracy. Yeah, 100%. In my case, I am getting 100%. Okay, So let us implement this particular part. Okay, now it's 10:59. So please finish this part by 11:03. So training of the random forest model followed by model evaluation. Okay, so then I will definitely share this portion in the comment box as well. So please finish this part. So this is up to getting the explanation. I mean, sorry, getting the accuracy. Okay, so how much predictions we are making. Followed by that, in the next step, we will see the generation of the explanation. Okay, with the help of line, with the help of shape, that how can we generate the explanation and how can we interpret the explanation. That is also important because there will some pictorial representation will come up, and how to write them, that is very much important. So those who write the company white papers, or those who are writing the project reports, or writing research papers, so all of you are quite aware, because all of the respected faculty members, you have done your PhD. So it is very much important that not only to generate the figures by executing the code successfully, but how to interpret them, how to write them properly, explain them properly. That is very much important when you are writing journal papers, conference papers. So because of that, I have added the explanation with my best capacity. So I hope that it will help you. Mm. So this notebook will be given to you, so you can take them as a standard template. Definitely will edit as per the data set, different data set. You have to edit it and make the necessary changes, but you can consider them as a standard template so that you can easily play around with it. Okay. So in this step, I repeat, we are training the random forest model and then finally evaluating the model performance and checking the accuracy. Okay. So as the time is over, let me just go back to the Q&A section and post it. So I am posting it in two parts, okay, to avoid any kind of the problem, because there will be word limitations. So first portion I am posting sequentially, training of the random forest model. Okay. In the first section, I am posting that. And in the second section, I will post the model evaluation part. Okay. So it should go properly. I hope there should not be any difficulty. Okay. So it went smoothly. Okay, fine. So you can check it went smoothly. Okay. Now in the next part, I am putting the model evaluation part. Okay. Okay. So it also went smoothly. Okay, fine. Okay. So entire delivery has been done. Now please check. Let me go back to the original picture. Okay. Okay, so just cross check once. Those who have finished it, fine. Those who are doing it, please just cross check how the alignment will come. Okay. So first will be the training of the random forest model and then model evaluation. Okay. In this way, the entire thing will come. Fine. So now let us move to the next part. That will be the line-based explanation generation for the iris flower classification. Okay. So what we shall do here? So main objective will be to check use line for explaining the model predictions. So that would be our main objective here. Okay. So first step, what we shall do? We shall do the implementation of the line pip install line. Okay. And after that, what we shall do? We shall import line. So from line import line tabular. So what it will do? It will import the line tabular module from the line library. Okay. So that you can easily enable the explanation for all the tabular data models. Okay. And then what we shall do? We shall create the line explainer. Okay. So before going to that, please implement up to these two steps, these two simple steps. Then we shall create the line explainer. So it's now 11:06. Please finish by 11:09. So I repeat here, we are importing line tabular module from line library so that it can enable the explanation from the tabular data models. Okay, and for your assistant purpose, all the necessary comments are added there so that those who are new to it, not only they can practice the code or they can access the relevant theory from the added text section, they can also understand the each every line of the code. Okay. So hope all of you have been able to finish it, but still for your assistance, let me share it in the comment box section. So I posted it in the comment box section, sorry, Q&A section. Just check it. So let me go back to the original notebook. Okay, now in the next section, what we will discuss, we shall talk about the creation of the Lime explainer. Okay, so here what we will do, we'll use the basically the we'll use the lime underscore tabular dot lime tabular explainer. Okay, so in the first argument section, we will take the extrain values. Then in the second argument section, we shall take the feature underscore names equals to x columns, and followed by that we shall put up the class name equals to the target names. Okay, and discretize continuous equals to true. So basically we will initialize all the lime explainer value to there. Okay, and we will put up and assign this as the explainer variable. Okay, now for example, we want to select a sample prediction to explain. Okay, so for example, if Python is a zero indexing language, okay, so we will start from zero. Okay, so if I am keeping I equals to 5, that means it will be the sixth instance. Okay, sixth test instance for the prediction purpose. Okay, so for example, here you remember that we have the entire data set is 150 samples. Okay, so 30% of you, if you are taking for the test sample, that means it will be 45. Okay, and remaining 105 will be for the training. Okay, so you can try out any of those out of 45, you can try out any of those test samples. So the index will be 0 to 44. So here we have taken the I equals to 5 and we are selecting the sixth test instance, and followed by that exp equals to explainer dot explain underscore instance. Okay, we are keeping the x test values I. Okay, and then model dot predict proba. Okay, we are putting as the second argument, and then we are keeping the number of features equals to 2. So it will generate the explanation using the models predictability. Okay, models probability predictions. Okay, and we are focusing here on the top two features. Okay, so that's why num features equals to 2. And then at the final step, what you can do, you can display the explanation using the exp.show underscoring underscore notebook. So you will get the following output. I will explain the output one by one. Okay, and for your assistant purpose, I have also kept the all those explanations. Okay, but first you complete this step. Okay, and then I will explain what we are getting at the output and how you can interpret the explainability of live model. Okay, so it's now 11:13. So please finish this step by 11:17. So I shall wait for a couple of minutes more. So hope you are typing. I'm requesting all of you to please type. And then, as usual, I will definitely put this part in the Q&A section. So you can easily access those codes. Now let me put this part in the Q&A section. In the first part, I am putting only the creation of the lime explainer. Okay, so I will put it in 3 segments. So in the first part, I am putting the creation of the lime explainer. Okay, so this is the first part. Okay, it has been posted successfully. Let me cross check whether the entire portion has gone or not. Okay, so entire portion has been delivered. Now in the next part, so basically I will put the second part, selection of a sample prediction to explain. Okay, hopefully it will go fully. Let me check. Okay, so okay, not okay. So second part, I have to post. Okay, I equals to 5. You can do. I am reposting the second line, which has not been fully delivered. Okay, second line, in the second line, we are using the explainer dot explain underscore instance function, where we are defining x test values. Okay, model dot predict underscore proba and number of features too, where we are explaining that basically we are focusing on the top two influential features for explaining the model's probability predictions. Okay, so I am only posting the second line of this segment. Hope it will go fully. Okay, the second line has been posted successfully. It went fully. So model.predict underscore proba stands for the model's probability predictions. Okay, and num feature underscore features 2 means you are focusing on the top 2 features. And the last part, displaying the explanation, I am posting the last segment, that is exp.show underscore in underscore notebook. So it will display the explanation part. Okay, so you will get the idea of the explanation. Okay, so I posted it also. Now let me go back to the original notebook. Okay. So just check, just cross check once. Okay. So while aligning one by one, those who already have done successfully, fine. But those who are still doing it, so please align it properly. So in the first segment, put create line explainer, then selection of a sample prediction to explain, and then finally the displaying of the explanation. Okay. So just align them properly. Okay. So it will come sequentially one by one, and you can do it properly. Okay, so I'm waiting for those who are unable to do it so that they can align it properly and reproduce this section successfully. Then we shall move to the interpretation of the output. Okay, because we will get some figure. Okay, and we have to interpret. That is the most important part. How to interpret them properly. 11:21. So I shall wait one more minute. Okay, so that all of you can put it in proper way. In case you made some error or those things, you can correct it, and then we shall go for the interpretation part. For a few more seconds and then move to the next part. So hope all of you are doing it. Okay, now let us move ahead. So once you see, so there will be this type of the output. Once we implement it, so you will see the prediction probabilities, contributing features, okay, and feature values. These three types of the categories you will get. So last, like from the first part, okay, see the left hand side, the probability prediction. Okay, so if we look at very carefully, so this particular image is basically gives you the idea that how the machine learning model output can be explained in a proper way with the lime method, okay, or the lime tool. And lime stands for the local interpretable model agnostic explanations, those who are new to it. So for them I again added here the full form. So here the prediction probability is what you are getting. This model setosa, if you see the first class, because I told you that iris setosa, iris versicolor, iris britannica, there are three classes, and each class consists of the 50-50 samples. Okay, so that altogether 150. So it's a very well balanced data set. So now the model prediction, as you can see, it has appeared 1.000. That means the model predicted class setosa with a probability of 100% confidence. Probability 1 means 100% confidence. Okay, and Virginica and versicolor, you see in the box 0.00. That means it is indicating that they have the probability 0. Okay, that means there is no confidence in those classes for this particular prediction. Okay, I think the left hand side prediction probabilities part is now clear how it is interpreting. Okay, now in terms of the contributing features, not versicolor, for example. Okay, so here you see, if we talk about this particular segment, so petal width in centimeter less than equals to 0.40. Okay, you can see the contribution score 0.21. Okay, so it to the predictions of not being versicolor. Okay, or even interestingly, if we see this next part, petal length centimeter less than equals to 1.70. Okay, 0.59 is your contribution score. Sorry, 0.19 is your contribution score. So it is actually implementing that first feature, which is the petal width less than equals to 0.40. Okay, this feature contributes 0.21 contribution score to the prediction of not versicolor. Petal length less than equals to 1.70 with contribution score 0.19. That means it is contributing towards predicting not versicolor. So versicolor, not versicolor. Okay, there are two parts. So it is actually contributing towards the not versicolor segment, as the figure suggests. Okay, and then the feature values. Look at very carefully. The feature values are 0.40 and 1.50. That's why it is comparing either exact with this value or nearby this value. Okay, the entire comparisons are being made. Okay, so these are the feature values. Petal width, petal length. These two important features are being considered. Okay, along with their feature values, and on the basis of that, you see the prediction probabilities have been made. Okay, so there are three segments. If we see the prediction probabilities, contributing features, and the feature values. The same thing has been highlighted here. Okay, the actual values for these features for this instance are petal length with 0.40 and petal length 1.50, and all the units are given in the centimeter. Okay, so the visualization suggests that the model prediction of the setosa is strongly supported by petal width and petal length. And if we have seen, some threshold values are also attached there for the versicolor and virginica. Okay, like for example, here we have seen petal length and petal width, some values are given there, and with certain comparisons we are showing that it is not versicolor case. Okay, so because versicolor is the next vicinity of the setosa. Okay, vicinity class of the setosa, so that's why it has been shown here also. Okay, so similarly, we can do another interesting example to check that if we change the sample, okay, some change the test instance, so you can get some type of the other type of the interpretation. Okay, so let us try it out. Okay, let us check that way how much it will give us, uh, how much it will give us the the proper predictions or proper explanations while implementing it. Okay, so this is the next example. So you got some idea that how to interpret the line output. Okay, so this is you can consider this one as the standard template. So for your own analysis purpose, definitely depending on the data set, output will change. So accordingly you will just change those things, but overall you can make this way. So there are three important part while interpreting the output. One is the prediction probabilities, then contributing features, and followed by the feature values. Okay, and accordingly you can make the necessary outputs. Okay, so this is for the lime part, and we shall also check another interesting case related to lime. Okay, so you can import lime from lime, import lime tabular. This is the similar steps. Okay, and then what you have to do, you have to just initialize it. So explainer equals to lime underscore tabular, lime tabular explainer. So you will basically create the lime explainer with the help of the extend dot values, feature underscore names, x columns, and class names, data target values, and then discretize continuous to. So finish up to this first three steps, then we shall go for the selection of the instance. So here we are taking the first instance, so I equals to 0 will be taken. Earlier we have taken the sixth instance, that's why I equals to 5 we have taken. Okay, so here we are taking the different test instance for generating the explanation. Okay, so just take this and let me know once we can once we are done with it. So it's now 11:31. So please finish this step by 11:34. Okay. Then we shall move ahead for selecting the sample prediction for the explaining and then displaying the explanation. So we will have similar type of the output, and we will try to figure out that how to explain them in a proper manner. So I hope that all of you are doing it. Okay, so those who are uh, still doing it, for them I shall wait for a couple of minutes more, because I told you that I wait till 11:34. It's now 11:32. Okay, so let me share this portion in the Q&A part, so that all of you can do this portion smoothly. So I am putting it in two parts. So in the first part, importing line will be there. Okay, so that it can deliver smoothly. Okay, so this part I think it should go fully. Let me check. Okay, so it's delivered smoothly. Now in the second part, creating line explainer. Okay, the standard step. So I'm putting it in the second part. I think it should go fully. Let me check. Great. So it has been delivered fully. So those who are doing it, just cross check with me. Those who already done it successfully, then fine. Just for others, I have to. Okay, so just align it. You can do pip install lime again and then importing lime and then creating of the lime explainer. Just put this thing and just cross check. I'm waiting for a few more seconds so that you can, all of us can be in same page. Okay. Well, so I think all of you have done it. So let us see now next part, selection of a sample prediction to explain purpose. So like in earlier case, we have done I equals to 5. That was the sixth instance. Like I told you that Python is a zero indexing language. So we always start from zero. So here we are taking first instance. So that means it will be I equals to 0. Okay. And then in the next part, generating the explanation on the model probability prediction for the top two features. So what we'll do, as we are taking the top two features, so explain exp equals to explainer dot explain underscore instance, same function will be there. Test x text values I, index I, then model dot predict underscore proa for the predicting the model probability predictions, and then number of features will be 2 as we are taking top two features. And finally, the display the explanation. So xp dot show underscore in underscore node. That is the standard part. Okay. So please finish this portion. So it's now 11:38. So please finish this portion by 11:41. Then we shall see the output and definitely we'll discuss about the output explanations. So I believe that all of you have been able to complete this part, and those who are still doing it for their assistance, or those who are unable to do it for their assistance, I am putting it in the comment box, Q&A section. So from the previous experience, I am splitting it in three parts. Okay, so I am putting I equals to 0 separately. Because altogether it will not go. Okay. So under the selection of the sample prediction to explain, I'm putting this one separately. Okay, I equals to 0, done. Then in the next part, explainer.explain instance, so model.predict underscore proba. Okay, so basically probability prediction for the top two features. It will go. Next part done. Then displaying of the explanation, exp.show underscore in underscore notebook. Okay, then the final portion I am sharing here. Okay, so just have a look. Okay, align them and just have a look with the original notebook. I am going back to my original notebook. Just match with it. Just have a look at it and match with it. So just match with it. I am waiting for a few more seconds and then we shall go for explaining the output. Okay, so I hope now all of you have done it. So here also see the first portion which we are getting from the Lime output as an explanation generation for the machine learning model prediction. That is the prediction probabilities. So in the prediction probability, interestingly, you see here, okay, what we are getting? We are getting versicolor probability predicting the versicolor class with the probability is 0.97. That means it is the confidence score is 97%. Whereas Virginica has the probability score of the 0.03. That means 3% confidence. 0.03 probability means 3% is the confidence score, and Setosa having the 0 probability. Okay, so this is the part of the prediction probabilities. Now let us see not versicolor, versicolor. So obviously it is predicting versicolor, so it should appear in the right side, unlike the earlier case where we have seen all the things are happening in the not versicolor. So if we compare with the top contributing features of the classification, okay, so petal length centimeter in centimeter, the units are in centimeter. So petal length less than equals to 4.30. Okay, so it will have, if you see contribution score 0.19. Okay, so the contribution score is feature contribution score is 0.19. Okay, it is predicting towards versicolor. Okay, petal width with the centimeter less than 2 0.40. Okay, so it is having the contribution score 0.27. Okay, so this is how you can see these features are positively influencing the decision, pushing the model towards predicting mainly versicolor. There are very few confidence score, 3% confidence score that it will be virginic. Otherwise, it is versicolor. Okay, so this is how you can interpret whatever you are visualizing in the contributing features, and then feature and their values. So here, what we are considering as the in general case, what is the reference frame? The petal width with 0.40, petal width 1.20. These are the top two features because already in the code we have mentioned that number of the features two most important contributing features we are considering. There are four features: sepal length, sepal width, petal width, and we are considering two most contributing features. So that's why petal length and petal width it has been highlighted here. Feature and their corresponding value. This is the last part of the interpretability. Feature and their values. Okay. So these values are significantly larger than the thresholds set for differentiating the different classes and leading the model to strongly predict that the flower belongs to the versicolor class. Okay, so this particular part we are done. I hope the line part is now quite clear to you. Okay, so we can gradually move towards the shape based explanation generation for iris flower classification. Okay, so what will be the objective? Simple objective, like the way we have discussed, that use shape to explain model predictions. Okay, and model explanation part, the multi-class handling. So the code checks if shape values is a list, which indicates a multi-class model. So in such cases, it selects the shape values for the second class. Okay, so shape index value will be 1. Okay, because you see it's a zero indexing language. So SAP values 1 means first class. SAP values, if we want to predict second class, so index value will be 1. And the binary and the regression handling, what will happen? That if SAP underscore values is not in a list, it directly uses SAP values for plotting. Okay. So let us see. So first step, import SAP. Okay. And then what we will do? We shall create the SAP explainer. Okay. So SAP.tree explainer model, we'll put it under explainer, and then explainer.shape underscore values xtest, we will keep it under shape values. Okay, so these three lines you just implement. Okay, it's now 10:49, so please finish this step by 10:52. Sorry, it's 11:49, so please finish these steps by 11:52. Okay, then I will definitely share these things in the comment box, Q&A section, so all of you can do it, but I encourage you to type it. Okay, so in this part, importing of the shape and creating shape explainer part, we are incorporating. Okay, so please type carefully. You do not have to hurry up because it's a learning process. Okay, so just go slow. Those who already know it, please consider them as a good practice. There is no harm in repetition of practices. And those who are new to it, hope you are gaining some experiences. And these all resources will be given to you. You can practice out at your home with different data sets. Uh, all the steps have been explained, and figures, all the figures which you are getting, interpolation has been added there. Like I mentioned, and I repeat that you can consider them as a reference item. Data wise, it will change, output will change, you will change the values, and change will other necessary items. That's it. Okay. So nothing to worry about it. I hope after this session you will gain some positive insight about the explainable AI. You can use it for your own research. You can use it for your own teaching purpose, whatever you prefer. So I shall wait for another more minute and then I will share it and move to the next part. Okay, so let me share this portion in the Q&A part. Okay, so those who are still doing it or unable to do it, they can just cross check once. So just a second. So in the first section, I am keeping import shape. Okay, the basic line I am putting here. Import shape. Okay, so first section is done. In the next section, I am keeping explainer equals to shape.tree explainer model. Okay, so in the creating the SAP explainer, I am putting it in two part. Okay, just to avoid any kind of the discrepancy. Sometimes it may not, because of the word limitation, it may not go fully. So that's why first line I have put the explainer equals to shape.tree explainer model part. In the second line, I am putting shape underscore values explainer dot shape values xtext. Okay. Okay, so I have shared the entire part. Just cross check with my screen. Okay, I am just going back to my original screen. Just cross check. Okay, I'm waiting for a few more seconds. Just check it. Then we shall go for the implementation purpose. Okay, so let me start explaining next part. So check, first of all, we will see, check if the model is multi-class. So if is instance SAP values list. Okay, and for multi-class SAP values will be an array of list of arrays. Okay, so that's why SAP dot summary underscore plot SAP values underscore SAP underscore values one xtest feature names xtest dot columns. So here you check. I already added above that if the it is a multi-class, in that case SAP values will select for the second class SAP underscore values one. Okay, if it is not the multi-class case, if it is a binary case, then what will happen that for binary case, what it will do, it will SAP underscore summary plot SAP values xtest SAP feature names. Okay, so it will show xtest columns, so it will show as a plot. If SAP values is not a list, so it directly uses the SAP values for plotting. Okay, so this is the plot, and this is the this SAP interaction values. Okay, so before I go to explain this particular portion, you just implement this part. So just remember, if it is a multi-class, then there will be a list of arrays. If it is a binary class or regression model, it will be a single array. Okay, so when you are putting them, the code will remain same. Just remember SAP dot summary underscore plot. Definitely, it will be an if-else statement. Simple in code. Though, as you are from the computer background, so I don't have to explain all those things. So it will be a simple if-else statement. So as per the provision, you just have to write SAP underscore values in index. There will be one. Okay, as you are choosing the second value. Okay, for the regression for the multi-class case, and if it is a binary case, you don't have to write anything in the index. SAP underscore values will serve the purpose in the past argument section under the SAP dot summary underscore plot. Okay, rest of the case will remain same. Okay, so this is the overall scenario. Okay, so this is how you can create the SAP explainer and check the output. So this is the simple if else statement. This is the simple if else statement. So just let me know once you are done with it. So it's now 11:59. So please finish this step by 12 to. And then what I will do, I will move to the your Q&A section and I will put this particular chunk of the code there. Okay. So for your assistance, I am putting this particular segment of the code in your Q&A section as well. So you can easily do this part. So what I'm doing, I'm putting in three segments. Okay, so first one is the else statement. Under the if else statement, the multi-class part, this will be the first chunk portion of the code under the if else statement so that it can go fully because there will be word limitations. Okay. And then this if else part, next portion. I hope it will go fully. Okay, so this portion also done. And the final one. If it is not the multi-class, if it is a binary class, then what will be the SHAP summary plot? Okay, so okay, it will I think it will go fully. Okay, so entire part has been sent to you. Okay, so let me go back to the original notebook. Just have a look at it. So we are done with this particular portion. I will just explain the plot here, that how we are interpreting it. Now the interpretation part is important, that how will you interpret this portion. So just have a look at this part. I hope you have aligned it properly. So just remember the step, importing SHAP, then creating the SHAP explainer for the explanation generation purpose. Then check if the model is multi-class. Otherwise, if else, there will be if else loop. So next part will be that to make the prediction. Okay, so if it is multi-class, then this condition will be followed, else the other condition will be followed. So it's a standard if else statement. Okay, so just have a look at it. Okay, done. And then sepal length, sepal width. Okay, just check this type of the output you will get. The interaction values will be there, and this is the output. So for your understanding purpose, just I am giving you telling you the explanations. Okay, just a second. Give me 1 second. Okay, so now let me just go back and share the screen. So here you can see that there are vertical axes. Okay, so these vertical axes are basically giving you the idea of the sepal length, petal length, and so on. So sepal length, petal length, sepal width, these are the vertical axes. So you can see there are 3 vertical axes: sepal length, sepal width. Okay, and petal length is also there. Petal width is not there because it is not contributing significantly from the feature, so that has been omitted. Okay. Now, interestingly, if you see the plot, there are dots are appearing. So what does it mean by these dots? You can see in explainable AI, this understanding of the explainability is very much important. So here the output, the interactions values which you are getting. So here you see the dots. So these dots basically nothing but the SHAP interaction value. Okay. And in the next part, if you check that how much individual interaction values are representing that for individual predictions. Okay, now this horizontal spread are very much important. Okay, so for example, there are 2 types of the impact. If you see the positive impact, which is indicating the right hand side of this particular axis, and there can be negative impacts, which is showing the left hand part of this particular presentations. Okay, now the positive impact means that right side of the center, that means 0, it has having the positive impact. So this is the 0. Under that, if you see in the right hand side, it is spreading up to 0.25 value. In the left hand side, it is spreading up to minus 0.25 value. Okay, so it is spreading 2 sides, keeping center keeping 0 at the center. Okay, so this right hand part is the positive impact, the left hand part is in the negative impact. Okay, so now the color, the next point which comes to the color. So if you are seeing the red or the pink color, this is giving you the higher value. Okay, and those which are in the blue color, this is indicating in the lower feature value, higher feature value and lower feature value. So remember that this particular segment, whenever you are seeing in the red color or the pink color indication, these are the indicating the higher feature value. and those which are coming in the blue color, that is indicating the lower feature value. Okay, so two parts. One is the positive impact. There can be higher feature value which is contributing towards the positive impact, or higher feature value can contribute to the negative impact. Okay, or even in case of the lower feature value which can have the positive impact, also it can have the negative impact. Okay, so you have to see that whether they are in the right hand side of the zero. Okay, so it will have the positive impact. If it is going the left hand side of the zero, it will have the negative impact. And if it is the color is in red or pink, it will have the higher feature value. And if it is in blue, that means it is in the lower feature value. Okay, so in this way you can make the conclusion. So in a nutshell, what you can say in the feature impact, okay, this particular if you see the concluding line which I added there in the notebook, that petal length shows a wider spread along the axis. It indicates that it has a more substantial impact over the model predictions compared to the other features. Similarly, if we talk about the sepal length, sepal width, these can features also have a comparatively narrower spread. That means they have a lesser impact. Okay, so petal length, if we see, it has a wider impact comparatively to the other features, sepal length and sepal width. Okay, it has a wider feature spread, so it has a more impact in comparison to the other two features, sepal length and sepal width. So in this way, through the help of the explainable AI, you can actually generate the explanations, interpretable explanations in comparison to the according to the predictions which you got. Okay, so this sample write-up can give you a standard template which you can play around. Okay, so classifier will classify you, it will give you some predicted outcomes. Okay, but interpretability, to avoid the black box model of AI, the explainable AI plays a pivotal role. And you have seen the first half of the sessions we have discussed about the lime, SHAP, this type of the very much important explainable AI tools. Okay, we shall also discuss about the deep learning implementation, and where we will see the effect of the GradCam explainable AI tool, which stands for the gradient weighted class activation mapping. Okay, so that we will discuss also. Okay, so now I think the time is over. So already it's now 12:09. So I am concluding here and closing the first half of the session. So over to you, madam. If you have any query or questions, or the participants have any query questions, they can reach out to me.
Thank you, sir. Any question, participants? Is there any question, participants?
Yes, ma'am.
Yeah.
Hello, sir.
Yes, sir. Please.
Sir, you are using save a line with random forest. Can we use with other classifiers such as?
Definitely, there no problem. You can use that. No problem. I am giving you one example. Like I mentioned, that this is a standard template. You can play around with other type of the classifier, other type of the data sets. No problem.
Okay, sir.
Thank you, sir. Any other question, participants? Okay, then. Thank you, sir. It was very informative session. We'll meet again at 12. Participant, please join the session at 12:50 on time. We'll start the session till 1 o'clock. Okay. Thank you, sir.
Thank you very much. Thank you. Thanks.
Thank you, sir. Very nice session.
Thank you so much.
All
Thanks
of you,
to
please
all the
be
dynamic
there on
audience
time.
Thank you.
for their positive responses and making the session interactive. Thank you very much.